All right, so as promised, we have lesson 4. So we're module 6, lesson 4, 4th grade, obviously. And our objective is use meters to model the decomposition of one whole into hundredths. Represent and count hundredths. All right, so today's is definitely a little more confusing, for sure. I read over the lesson quite a few times, and obviously I understand it, but I'm trying to think of the best way to do it with you. It would be so much easier if I could just be there with you right now. This is one of those lessons where I really, really, really wish that we were together. It would be easier for everyone, but we're going to do the best we can because that's what we can do. So I'm supposed to show you a meter stick right now, and I don't have a meter stick there at school. But if we recall, a meter stick is it's like a yardstick. Remember, there was a difference between yards and meters. 1 meter has how many centimeters? So when we picture our meter stick that was close to a yardstick, it had, well, I didn't have a meter stick. But anyway, do you remember the yardsticks that we had? And we had meter sticks, and there was almost like a 3-inch difference between the two, or something close like that. So if I had a meter stick, we had to think, how many centimeters do we have? And at the very beginning of the year, we did module 1, and then module 2, we did centimeters and meters and different metric units at that point. So we figured out that 1 meter was 100 centimeters. Okay, so we're actually kind of going back to this today. This is very important for us. 1 meter has 100 centimeters. Okay, so if I'm going to draw, maybe I'll try to put that off in the corner. 1 meter equals 100 centimeters. Remember that module that we did, and most of the one of something was a 1,000, so like 1 gram and 1,000 kilograms and stuff like that. This was our only one with 100. So 1 meter was 100 centimeters. So if we take 1 meter, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1 meter. 1 meter. This would be 100 centimeters, but what are you talking about? That's not 100, that's 10. So that would be 1/10 of a meter, right? And that would be 1/10 of a meter. So each of these is worth 1/10, but that's still 10, and we need 100. So what do we do for that? In that case, we would break each part up. 2, 3, 4, 5, 6, 7, 8, 9. We break each part up, and that's worth 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's where we get 100 from. So each little teeny tiny part is 1/100th, correct? Like each little teeny tiny part, if I did that for all of those, I would have 100 or 100 centimeters. So 1/100th. So each little one is worth 1/100th. That big guy is 1/10. So this is kind of the tricky part today, that we have to get it through our heads that this would represent 1/10 of a meter, and this would actually, not centimeters, sorry, that would be 1 meter. And each little part here would be 1/100th of a meter, which is 1 centimeter. So 1 centimeter is actually equal to 1/100th of a meter. Okay, so 1 centimeter is worth 1/100th of a meter, and we have 100 meters going across. So I am definitely, well, I walk you through all the problem sets, but I'm definitely going to walk you through this one slowly. So this one, as I was telling you earlier, if you were in our Zoom, it's going to take a little bit longer. So I'm going to leave this here. And we're going to do a couple examples before we even get to the problem set and stuff. If we were trying to figure out 3/100ths of a meter, do you think you shade in 1, 2, 3, or do you think you shade in 3 of these? So for 1/100th, you're going to shade in just 3 of these. Did I say 1/100th? Excuse me. For 3/100ths, you're going to shade in. You have to picture 100 little guys here, and you are only going to shade in these 3. But what if it looked like this? 30/100ths. Okay, so, well, that would be 10, that would be 20, that would be 30, right? But if I shaded in all of these to get my 30/100ths of a meter, isn't that 1, 2, 3, isn't that 3/10? So 3/10 is equivalent to 30/100ths. And if we, let's pretend that is actually 10. I don't think it's really 10. If we shaded in all 3 of these would be 3/10, but it also would be 30/100ths. Now, remember that little trick that we can do to find equivalent fractions? Oh, I'm sorry, you can't see the bottom. If we multiplied this by 10 and multiplied this by 10, wouldn't we get 30/100ths? Okay, so we've got our equivalent fractions. Did I go further back? Yes. We have our equivalent fractions. So 3/10 is the same as 30/100ths. Now I'm going to erase this. Let's do a couple more of those. If I have, say, 6/10, how many hundredths would I have? Okay, so how do you get from 10 to 100? You multiply by 10, right? 6 times 10 is 60. So if I were to draw out 6/10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm coloring in 6/10. This is 6/10, right? If I broke each one of these up into the 10 parts, I'd have 10, 20, 30, 40, 50, 60. So I'd have 60/100ths. So this is super important to learn today. How about 35/100ths? How would I do 35/100ths? So 35/100ths, I'm going to try to do a decent job drawing this. Okay. I didn't do a very good job. All right, I left, so this one is kind of big on purpose. I know it's not drawn to scale, but sorry, but I need it like this. All right, how are we gonna do 35/100ths? So we have to picture that each of these is broken into 10 parts. Okay, so picture, so this is 1/10, right? This would be 2/10, 3/10, 4, 5, 6, 7, 8, 9, 10/10, right? So this is our meter. This whole thing is in meter. How do I do 35? Well, let's break these. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 7, 8, 9. 1, 2, 3, 4, 5. Okay, so let's pretend they're all broken into 10s, right? How do I do 35? I do 10, 20, 30. Oh, 1/10, 1/10, 1/10. How many tenths is that? That's 3/10. So I'm going to make this smaller. I want to show you. 35/100ths has 3/10. Oh goodness, you can't see it. write that better. That's better. 3/10 is the same as 30/100, right? 30/100, 3/10. And then we shade in 1, 2, 3, 4, 5. And so that has 5/100. Doesn't it look weird though? Because our 3/10 doesn't say 30/100, and the other one is in hundredths. But this is made of 3/10. Now in your head you can say, oh, 3/10 is equivalent to 30/100. Yes, it is. But we could just write 3/10. So this is a number bond that we're going to be working on. Oh, look at the number 35. That has 3/10 and 5 ones. Oh, okay. Well, that makes a little more sense to me. Our 3/10, we can write it like that. And then we have 5 ones, and that's 5 out of 100. Okay, all right. Not too bad. Okay, so we're going to use that knowledge to tackle our problem set now. Let me just see if there's something else that I wanted to go over. Nope, I just did that. I kind of jumped ahead, but you know me. All right, so the problem set, the very beginning, it kind of makes your head go a little, ugh, like what's going on? So just bear with me and just, you know, remember at the beginning of all this stuff, it's always difficult for us, right? And then we work on it and then we're like, oh, this wasn't that bad. Remember when we had like 5, I think it was 5 lessons when we did our metric unit, 5 or 6 lessons. Was it 5? And we were like, oh my gosh, this is so hard. And then by the end, we were experts at converting those numbers. So it's one of those times where you just kind of go along, all right? And you will pick it up. What is the length? So we're on the problem set, number 1A. What is the length of the shaded part of the meter stick in centimeters? All right, so they drew this 1, 2, 3, 4, 5, 6, 7, 8, 9. And they said this whole thing is 1 meter. And they colored in this. So that's 1/10 of a meter, right? But they want to know how many centimeters it would be. So how many centimeters is that? Well, for us to figure out how many centimeters it is, we have to break that into 10 parts, right? Oh, if we break that into 10 parts, how many centimeters is it? It's 10 centimeters. So 1/10 is equal to 10 centimeters. So the question is, what is this worth? This is worth 10 centimeters. Remember, there's 100 centimeters here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's worth 10 centimeters. So the answer to A is 10 centimeters. And 10 centimeters means 1/10 of a meter. What fraction of a meter is 1 centimeter? Oh my goodness. So if we have to break this, we can only color in 1, not 1/10, but 1 centimeter. 1, 2, 3, 4, 5, 6, 7, 8, well, 9. Sure. So let's color in this. That's 1 out of how many? They'd be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 1 centimeter is 1/100th of a meter. So 1 centimeter, remember centimeters are really tiny. It's 1/100th of a meter. So there's our answer to B. C, in fraction form, express the length of the shaded portion of the meter stick. Okay. It's the same thing shaded in, right? So this is worth, oh, I'm sorry, these are all shaded in, right? My apologies. That's worth 10 hundredths, right, of a meter, because there are 10 shaded in, but it's also worth 1/10 of a meter. This is 1/10, but if we broke all of these into 100 parts, we'd have 10 colored in out of 100 of them. So these are both the answers. You can write either one or you could write both of them. I would just write both of them, might as well, right? So now in D, we have to write it in decimal form. Well, that's okay. Now we're like, oh, we already know how to do that, right? How do we write 1/10? 0.1 meters. But this is 10 hundredths. Well, then we can write 0.10 meters. Do you really have to write that 0? No. But can you? Yes. There's our answer to D. What fraction, so E, what fraction of a meter is 10 centimeters? Well, we already did that. We did this in C. It's the same answer. What fraction of a meter is 10 centimeters? That's 10 centimeters out of 100, or 1/10 meter. So this is also the answer to E. So C and E were actually the same thing, but they wrote it a little bit different way, didn't they? They wanted you to be able to look at this and understand it, and now they're asking you, it's almost like the opposite way. Okay, well, 10 centimeters, so you have to picture the 10 shaded in here. All right, so now, so we did number 1, so congratulations, number 1 is done. Let's see what number 2 says. Number 2, it says 1/10 is how many hundredths? I don't know why I erased that, because I just need this constantly. 1, 2, 3, 4, 5, 6, 7, 8. No. 8, 9. That's terrible. That's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure. Okay. So fill in the blank. 1/10 is how many hundredths? Okay. So we know that these are each, actually, let me write it on here. These are each worth 1/10, right? But if we divide each of these into 10 parts, we'll have 100, right? So if I shade in all of these guys, how many did I shade in out of 100? I shaded in 10. So 1/10, but we also know that this is 1/10, right? I shaded in 1 out of 10 of these. 1/10 is the same as 10 hundredths. So all you have to do in number 2, it says 1/10 equals 10 hundredths. And they already wrote that part. So you're just writing in the number 10. Okay, and then B says 1/10 of a meter. Well, that would be 1/10 of a meter, right? So how many hundredths is it? Well, we know that. It is 10. So again, we are writing 10. C, this is where this really becomes useful. We have 2/10 of a meter. Well, if we have 2/10 shaded in, we'd have all of these. How? So now they're saying that's 20. So if we look at a 10, 20 out of how many? 100. So you write 100. Because if we shade in 20, we have 20 out of 100, because we would divide all of these into tens. All right, now they already did 3A for us. So we're going to go right on the back. I probably needed that too. So we're gonna do 3B. They don't give us a lot of room here to write. I'm not sure why, unless your book looks a little bit different than mine, which it might. We don't have a whole lot of room to write, so I just had to do it on the side. So what they did was they shaded in so they have this shaded in, and this shaded in, and then this is divided into 10. I obviously don't do that well. And they have 4 shaded in. I just wrote a little 4 there. Okay, so what we have to do is figure out, well, we're kind of figuring out what the number is, but we're also figuring out, or we're also making a number bond, which is, I showed you earlier when we did 35 hundredths. So this is 2/10, right, boys and girls? Plain and simple, that's 2/10. They have 4 shaded in. So it's for what? Is it 4/10? It's not 4/10. It's for, well, now we have to, in our head, we have to picture all of these are divided into groups of 10. So that's, how many do we have all together? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 4 100ths. So what we're really doing is adding these together to figure out what number this is. You probably already figured it out. Can we just add these? I mean, you can and you can at the same time. 2/10 is worth how many hundredths? 20. How did I get that? Well, 2/10, that would have 10 in there, and that would have 10 in there. 10, 20. You could also remind yourself that I do top and bottom. I multiply it by the same, I get 20 hundredths. But again, I want you to use your noggin there and say, well, this is 2/10. Each tenth has 10 in there, so 10, 20. So this gives us 24 hundredths. This is actually our number bond. They want you to do a number bond separately, but I kind of like showing you this setup like this. So now we have to write it in decimal form. Okay, well, we don't have a full one shaded in at all. And then we have 2/10 and 4 hundredths. Remember, boys and girls, when I showed you the place value chart at the beginning, even though we haven't even done a place value chart technically here, we had like our tens, our ones, our decimal, and then that was tenths, and then that is going to be hundredths. Okay, so our place value chart is different than like a normal thing. We have 0, and then we had 2/10, and then we had 4 hundredths. So the number is 0.24. So just kind of picture this in your head, this place value chart. Even like I said, even though it hasn't really come up, some of you need that reminder to picture it in your head. All right, so the next one has 3 of these shaded in. So how many tenths are shaded in? 3/10 are shaded in, right? 3/10, and 3/10 is worth 30 hundredths. So you can just kind of keep that in your head, 10, 20, 30. And then they have this divided, and they have, I'm going to pretend that's divided right now. They have 8 shaded in. Now, what is that 8 out of? Is it 8/10? Are there 8/10 shaded in? No, there are not 8/10 shaded in. There's 8 of this little part. So they divided that into tens, right? So 10, 20, 30, 40, 50. So that would be 8 out of 100. Okay? 8 out of 100, because they only had 8 little guys shaded in, and you have to picture all 100 little guys shaded in. Or not shaded in, but like all of these broken into 10 parts. So 3/10 plus 8 hundredths. Now we know 3/10 is worth 30 hundredths. So we add 30 plus 8, really. So it's 38 hundredths. Now that should have been labeled. 3/10, 8 ones. 3/10, 8 ones. 3/10, 8 ones. I want you to kind of think of it that way. All right, so this is so our decimal would be 3/10, really? 8 ones, so 38 hundredths. That's how you say it, 38 hundredths. I know, this is like a brand new world for us, isn't it? All right, part 4 you'll actually really like, I think, because we get to, I'm just gonna try to draw it not upside down right now for a second. 1, 2, 3, 4, 5, 6, 7. I didn't do a very good job. You would think, but all right. So we got the easy one first. They want us to draw or to shade an 8/10 of a meter. Well, this is broken into 10. 8 of them would be here. There we go. That's all we had to do on that one. Wasn't it lovely? Now, the next one says 7/100ths. So if we are talking about hundredths, we need to have each of these broken into 10. So we have 100. Now, I don't actually have to break all of them into 10, which is great. So in 7/100ths, are there any 10s here? No. I just put a little 0 there. There's no 10s there. We only have 7 1s. So let's break this into 10. You get to do it on yours too. It's hard. And we're going to color in 7 of these. And there's our 7/100ths. Yeah. It was a little hard, right? All right, the next one is 19/100ths of a meter, okay? This has 1 10 and 9 1s. That means we color in 1 10, and now we have to break this. That's terrible. Into 10 parts. Because remember, if we're at 100, that means they're each worth 10. And we color in 9 of them. And there is our 19/100ths. 10 plus 9 more is 19. 1 10, so 1 whole 10th, and 9 1s. So there's part 4, I guess. Now, here is our number bond. So 5 is A, B, C, and D here, and we have to do number bonds. Now, they are going to look weird to us. But say the words with me when I'm saying it, or say it on your own. See what you're pulling out. We have to break this into tenths and hundredths, okay? How many tenths are here? 1/10. So it's 1/10 of a meter. How many hundredths are here in this part? Because really there's 19/100ths, but there are 9/100ths. This is made from 1/10 and 9/100ths. If we were picturing that tape diagram that we just had, we'd have one hole, because this is the problem we just did. We'd have one hole and then we'd have 9 more. So that's worth 1/10 and 9/100ths. Now, so that's our number bond that we had to show. Now it wants you to do the decimal version of it. Okay, we certainly don't have one whole thing colored in. How many tenths? We have 1/10 and we have 9/100ths. And yes, I'm sure you just figured out all you have to do is put your decimal in front of the 19. Yeah, but this is where it comes from, okay? All right, so we just did A. Moving on to B. See, it's getting a little better right now, right? We have 28/100ths, excuse me. All right, so let's pull out, this has 2 tenths. So again, if we are picturing that meter stick, we would have 2 full ones, 1/10 and 1/10 for our 2 tenths, and then we have 8 in that third one. We have 8 little ones. So we have 2 tenths of a meter, and we have 8/100ths of a meter. That's our number bond. Okay, and what's our decimal? We don't have a full meter stick colored in or shaded in. We have 2 tenths and we have 8 hundredths, 28 hundredths. So this is said as 28 hundredths, 28 hundredths, said the same way. Okay, the C, we have 77 hundredths. So we have how many tenths? We have 7 tenths. You see, we have 7 tenths of a meter, and how we're right now, I'm picturing that tape diagram. I'm picturing 7 of them shaded in, and then I'm picturing that 8th one broken into 10 parts, and I'm going to color in 7 of those. Okay, our decimal, that says 77 hundredths, that says 7 tenths, and 7, not ones, but hundredths, because it's a little part of it. So this is 77 hundredths. Last one. It's gotten a little better, right? Each day it'll get a little better. We have 94 hundredths. So right now we are picturing that tape diagram, and we are picturing 10 of them, right? How many are already shaded in for us? 9 tenths. And then that leaves our 4 hundredths. So in that last box, we'd break it into 10 parts and we'd shade in 4 of them. What's our decimal? 94 hundredths. Well, these should all... Oh, it didn't say anything about meters, so we didn't really actually have to do that necessarily. So, all right, boys and girls. I hope you enjoyed this lesson. You might want to watch it more than once. It's up to you. But I'll see you tomorrow.